Hi, we're going to start simplifying radicals here. These are a little bit tougher than normal Algebra 1, Algebra 2 examples. So hopefully we can get to understanding these better and at a deeper level. So as we get going here, one of the tactics for reducing these is to look for the factors of the radicand, the number inside, that are perfect squares. So you see a number like 240 and you're thinking, that's like 24 times 10. And I know a factor of 24 is 4. So you might start by saying, okay, this radical could be rewritten as 4, or radical 4 times 60. We got to get to 240 out of these. So you look at that and you say, okay, great. This is good because I can break down radical 4 as just 2. Now we have to work on 60. Radical 60 can break down as well. Now we don't want to go with 6 times 10 here. You always want to gravitate towards factors that are showing any possible perfect square factors. So 4 times 15 would be a better route. And so again, we can break down this 4 to a 2. Don't forget, multiplicatively, we still have another 2 here. So now we get down to 2 times root 15. 15 is not prime, but its factorization only leads to primes. So we don't have any repeated factors here. Radical 3 times radical 5, neither of those are going to break down. So we will combine our coefficient. 2 times 2 is 4 times radical 15. And so this is the simplified radical for 240. It breaks down to 4 times radical 15. This next example is a little bit different. What we have here is a kind of a mixed radical, a number out front times a number in the radical, and then we have an expression, an irrational number here, root 6 minus 1. And so as we carry out that distributive multiplication, you might have a choice on your hands at first. You might think, well, does radical 30 reduce? And you can kind of work on your scratch paper and say, should I reduce that before I go to work on multiplication here? But this quickly leads to nowhere but 3 times 10, or possibly you could do 5 times 6, but also it's another dead end. So none of these are perfect square factors. I guess 2 times 15, kind of the same demise there. You just kind of hit these mutually prime kind of dead ends here. So that doesn't mean it won't reduce in the future. Let's take a look at what we get here. Any number inside the radical is going to get multiplied when you're globbing these all together. So 7 times 1, but 30 times 6. So you're going to end up with 180 in there. Okay. And then as we distribute to the end, of course, you get negative 1 times that will just leave you with negative 7 rad 30. So we do have a big radical here. We know rad 30 is done, but 180, okay? So you see 180, you see 18. It makes you want to pull a 9 out, so that's fine. Radical 9 times radical 20. Okay, don't forget we have a 7 waiting out front multiplicatively. And that radical 9 is great because we could break that down to a 3. Okay, so we have 7 times 3 times radical 20. And 20, okay, 20 again is not prime, and it has a radical 4. That's the biggest perfect square we could factor out of it. So this becomes a game of knowing your perfect square factors. So this will be 7 times 3 times 2 times radical 5, which if we clean that up, what's that going to be? 42 radical 5. And then, of course, don't forget we had this part of the expression as well. So minus 7 radical 30. Oops, radical 30. There we go. And the last example I want to show is a bigger number. So the square root of 512. Now, I'm sure there's a few of you out there that are friends with 512, and you know all about this, and you maybe jump to a conclusion about how this is going to reduce quicker than some might, because it is kind of a well-known number. It's a power of 2. But let's say you're not super familiar with 512. You look at that and you go, well, I mean, it's even. So in terms of factoring, all I can really do is take a 2 out, and that feels like a dead end until you see what's left. Ooh, 256 is still even. So I keep taking these 2's out. Well, I should say radical 2's. And I keep getting these leftover even numbers. And here we go. We just keep going until you see something that reminds you of a perfect square. And here it is. So 64, radical 64 is 8. But all along the way, we kind of collected these radical 2's. Okay. So you could kind of bunch that all up and call it, radical 8 times 8, which is better written 8 times radical 8. But you're not done because 8 left inside there still has some perfect square factors. 4, it has 4. So break that down. Square root of 4 is 2. Of course, radical 2 is left behind, and we still have an 8 to multiply. So we end up with 16 radical 2 is what we get for the square root of 512.